We designed this telescope to see the very first galaxies that turned on in the universe, and when we saw what it did in only 12 hours, we knew in our hearts that whatever's out there, we're going to see it.
A serious problem has emerged in the field of astronomy, as recent discoveries by the Webb telescope have thrown light on unknown aspects of our universe. Normally, everything in the universe has a beginning and an end, but does the same apply to our universe? Well, our physics theories say that our universe began about 14 billion years ago. However, recent observations using our most advanced telescope suggest that the universe we're studying might not have had a distinct beginning. The recently launched James Webb telescope has surprised us with unexpected revelations about the early universe. New images from this telescope reveal that the distant past of the universe doesn't appear drastically different from our current universe. This poses a significant challenge for astronomy. Think about this. If our universe truly had a beginning, then when we peer back into its early stages, we'd expect to spot fewer galaxies, perhaps with odd shapes, smaller sizes, and mainly made up of lighter elements such as hydrogen and helium. But surprisingly, when the Webb telescope captured these early distant galaxies, scientists found that the galaxies were incredibly massive and bright, with some galaxies even larger than our own Milky Way. Well, not only this, recently, the Webb telescope has discovered many more strange galaxies. This discovery raised a big question. Why are we seeing the same universe billions of light years away? Well, the Webb telescope really deserves to be a competitor to our current theories about the universe, because each image from the Webb telescope continues to challenge our current understanding. Scientists are discovering unexpected things in every Webb image. So what exactly is going wrong with our current model? And could the latest discovery from the Webb telescope be a nightmare for science? The James Webb telescope recently captured an incredible sight, the most distant galaxy ever observed, named GZ13. This galaxy existed around 350 million years after the Big Bang, giving us a remarkable glimpse into the very early stages of the universe's formation. What we are seeing here is the last massive structure to exist at the very edge of our observable universe. This galaxy marks the farthest confirmed discovery yet, but the Webb telescope has identified numerous other potential galaxies at even greater distances that still need verification. Some of these galaxies have a redshift of about 20, which is unbelievable and completely breaks our standard cosmological models. The Webb telescope also found the second and fourth most distant confirmed galaxies ever observed. You will be shocked to know that this discovery has made the observable universe much wider. There are other cosmic structures beyond these most distant galaxies, but light from those objects has yet to reach the Webb telescope's mirror. More distant galaxies will be discovered in the coming future, and unveiling a much broader frontier at the edge of what we can observe in the universe. But light from some objects will never reach us, because at a certain distance beyond the cosmic horizon, the speed of light is being dominated by the rapidly accelerating expansion of our universe. Some galaxies beyond the cosmic horizon are moving away faster than their light is coming toward us. Adding fuel to this ongoing crisis in cosmology, Webb discovered galaxies much larger than our own just 700 million years after the Big Bang, with masses 1 trillion times that of our Sun or 10 times the size of the Milky Way galaxy. These potential galaxies were somehow as mature as our 13-billion-year-old galaxy is now. Erica Nelson, an assistant professor of astrophysics at the University of Colorado Boulder and a co-author of the paper, said that, "You just don't expect the early universe to be able to organize itself that quickly. These galaxies should not have had time to form. Another unprecedented discovery also revealed that some of the young early galaxies contain heavy elements like our present-day galaxies, which is not possible with their age according to our current model. According to the early results, so-called teenage galaxies, which formed 2 to 3 billion years after the Big Bang, are unusually hot and contain unexpected elements like nickel, which are notoriously difficult to observe. The amazing fact is that our Sun is 4 billion years old, and most of its heavier metals are inherited from previous generations of stars, which took about 8 billion years to form. So how is it possible that within just 1 billion years, the stars in a galaxy begin to form heavy elements? Lead author Alison Strom from Northwestern University said, "Never in my wildest dreams did I imagine we would see nickel." So what we have seen so far is that the early universe that exists billions of light years away from us is surprisingly similar to the present universe. These discoveries challenge our view that the universe began about 14 billion years ago. Even the most powerful supercomputer simulation, based on physics theories, fails to resolve the observations made by the James Webb telescope. Many scientists are claiming that we may be wrong about the age of our universe. On the other hand, some scientists believe that perhaps our universe had no beginning.
The obvious question is, where does it all start? I mean, and what is that significant event that starts it all off?
Well, the philosophy here, although in detail completely different, is like the old steady-state model. That was one of the reasons. You know, when you go back and you think of what Newton thought, and thought of what Einstein thought, they were very happy with a universe which was there all the time, you see. And there wasn't a beginning. In fact, Einstein fought against, when Lemaitre tried to convince him that there really was this, what we now call a Big Bang origin, he didn't like the idea at all, but he had to be converted to it by the equations seem to tell you that you can't get away with it otherwise. And then people got accustomed to the Big Bang being there. Or not just being there. You see, I'm claiming it is there, but it's not the beginning.
Well, another major discovery of the Webb telescope has revealed that there is a discrepancy in the value of the expansion rate of our universe. According to the cosmic microwave background, this expansion is happening at the rate of about 67.5 kilometers per second per megaparsec. Meanwhile, measuring the distance of Cepheid stars discovered by the Webb telescope leaves us with an estimated expansion rate of 73 kilometers per second per megaparsec. After this major discovery, some scientists are claiming that cosmic microwave background radiation is probably not a remnant of the Big Bang. Well, the cosmic microwave background radiation is the last observed glow of our early universe. It is the backbone of the Big Bang model. Our standard cosmological model is based entirely on how the universe evolved from the cosmic background radiation to the present universe. These Webb telescope discoveries implies that the universe may have had no beginning, that it has simply always existed. What we perceive as the Big Bang may have been just a particular moment in the evolution of this always existing causal set, not a true beginning. There's still a lot of work to be done, however. It's not clear yet if this no-beginning causal approach can allow for physical theories that we can work with to describe the complex evolution of the universe during the Big Bang. If you have watched this video completely, then do not forget to comment your thoughts about these discoveries. Thank you.